Hello students, and welcome to another video. I'm teacher Mr. Flynn, and today we're going to be calculating the grams of solute in a solution. So this is something I do quite frequently in class, is I have to create these solutions of barium chloride and copper chloride in my back room. And what I do is I weigh out a specific amount of this barium chloride, and I pour it into here and I dissolve it in the solution, and I dissolve it in this volumetric flask to make a solution. And it's a very specific amount of barium chloride. But how much do I put in here? How much barium chloride of this salt do I put in here to dissolve to get 0.1? Well, that's what these problems are designed to do. And the goal of this is to find the amount of barium chloride I need to make a desired amount of solution. That could be a liter. It could be 250 milliliters, right? Because these are 250 milliliters. I think you can read it right there. It's kind of hard to see if I kind of put in the light. 250 milliliters. Okay, but in this problem, I want to make lithium hydroxide, and I want to make 50 milliliters of it, and I want to have a 0.5 molar solution. Okay, so what I'm going to do is I have to start with the given volume. So I have 50 milliliters. That's how much I want to make. And I set up my picket fence. Okay. Now, I can't work with milliliters. I have to convert them into liters so I can compare it to my molarity of my desired solution. So if I convert this to liters, there's 1,000 milliliters per liter. So those cancel. So now I have my liters. And now I can use the 0.5 M solution. It got broke up, but it's okay. I'm going to make use of it. And this is equal to moles per liter. So when I put this in, 0.5 moles per liter, my liters now cancel, and I'm now left with moles. And knowing what we've learned about conversions, I can convert my moles into grams. So this requires me to find the molar mass of lithium hydroxide. So the molar mass of lithium hydroxide, I'm just going to punch it in as we go. So lithium is 6.94. And I'm going to add that to high oxygen, which is 16, plus hydrogen, which is 1.008. I add that together, I get 23.99. So this is going to be 23.99 grams of LiOH per mole. And I cross these out, and I'm now left with grams of lithium hydroxide. What I'm trying to find is how much lithium hydroxide do I need to make this much solution at this concentration. So if we look at this, this is our desired amount of for this solution. So this is a desired amount. This is a proportion to convert this. So this is a true statement that's changing our units. And then I compare it to the concentration that I'm needed. And then I do a molar mass conversion. So what I'm going to do here is I'm going to do all the math. So I'm going to do 50 times 0.5 times 23.99. And I divide that, I multiply that, and then I divide by 1,000, because that's what's on the bottom. So 1,000 times 1. So that's equal to 0.0, we'll just do 6 grams of LiOH. So to make a 50 milliliter solution at 0.5 molarity, I'm only going to require 0.06 grams. And if you've ever worked with a scale, that's a very small amount. That's all I need in order to create that desired amount. Okay. All right. So let's do another one. Okay. And this time, we're making copper chloride. Oh, that's actually pretty close to what I got here. So if you look here, I've got some copper chloride made, but it's 1 molar. I want something that's 0.5 molar, which is about half as strong. I want something that's cut in half. I want a weaker, not necessarily weaker, but just a less concentrated, more dilute solution. So in order to do this, okay, the first thing you got to do is you got to find the desired amount that you want. Okay, we want to make 250 milliliters. But can I work with milliliters? No, so I need to convert this into liters. So 1,000 milliliters is equal to a liter. My milliliters cancel, and now I can use this to compare it to my concentration, which big M is equal to moles per liter. So I have 0.5 moles per liter. My liters cancel, and now I'm left with 0.5 moles. Now I can convert my moles into grams, but the molar mass I have to find on my periodic table. So in order to do this, I have to do copper chloride. So I have 1 copper and 2 chlorines. So copper is right here, and it's equal to 63.55 grams. And I I add that to my chlorine, which is 35.45, but I have 2 of them. So I'm going to multiply it by 2 and put it into brackets like that. That gives me a molar mass of 134.45 grams per mole. And my moles cancel, and I'm now left with grams of CuCl2. So when I multiply this all the way across, I do 250. Can you see that? I might cut it off. Yeah. 250 times 0.5 times 134.45. And then I divide by 1,000, and that gives me 16.81 grams of CuCl2. So I'm going to need to weigh out on my scale 16.81 grams of copper chloride, and then I'm going to have to fill up my volumetric flask later with some water, and I dissolve it in here, and I can fill it up to this little line right here on the flask. And we're going to be doing this in class. I'm going to have you create some solutions. So this concentrated solution of 0.5 of copper chloride, it's going to need 16.81 grams. So if you're thinking about this, if this one's 1 molar, then that means I need to double this in order to make it 1 molar solution, if that's making sense. So I'm going to need about 33.62 grams in order to make a molar solution of this, like 1 mole solution of copper chloride in 250 milliliters. Okay? All right, so these problems can be kind of challenging because they're multi-step, but as you work through these practice problems, you'll get better at it over time. Okay? Thanks again for watching. Till next time.